So, question says figure 11.1 represents a nuclear fusion reaction where I see these two isotopes, they are combining to form particle B and particle A. So, on a rough estimate or on seeing the equation, what I can see, it refers to this being a hydrogen isotope and it also refers to this being an hydrogen isotope. Now, what I am given with this, see, it says 1H3. That means this one represents proton, number of protons, and this 3 represents sum of nucleons, that is protons and nucleons. So I know that 1 is proton, so this is 1, and n is unknown. Their sum is total to 3. Then I get n equals to what? 2. That means this particular hydrogen atom has one proton, and I can label this as one proton and two neutrons. These two are neutrons. Fine. Then isotope of the hydrogen, it says 1H2. Then this means I'm having one proton, and by similar calculations, that means 1 plus n is equals to 2. So n would be again 1 and also 1 neutron. This represents 1 neutron. So when these two nuclei they fuse together, what I am having is particle B. Now, as I can see this in this figure, this one is labeled as a proton and this one is labeled as a proton. However, these particles are neutrons. How do I know this? Because I calculated number of protons and number of neutrons in this figure, and I also calculated number of protons and number of neutrons in this figure. It comes out to be 1 in 2, it comes out to be 1 in 1. This means this one particle, the black particle, must be a proton and the other particles are neutron. So, coming towards particle B, it is formed as a nuclear fused reaction. Fine. So it contains one proton and one proton. That means two protons and two neutrons. I can label these black as two protons, and I can label these as two neutrons. Fine. Now, coming towards the other part, now starting the question, it says at very high temperatures, nuclei of the two isotopes, that is 1H2 and 1,3H fuse together, energy is produced, and two new particles are formed, particle A and particle B. Explain what is meant by isotopes of hydrogen. So I can write isotopes are the nuclide of different atoms that contains same number of protons but different neutrons. Now, using figure 11.1, that means using this figure, state the number of neutrons in a nucleus of the isotope 1H3. So, if I am having 1H3, I need to answer this number of neutrons. So, I can underline this number of neutrons. So, this represents number of proton, that is one proton, and then this represents number of nucleons. This is 1 plus 3, I'm sorry, 1 plus n is equals to 3. That means n would be 2. So I can write this as 2. Name of particle A. So particle A, it must be what? A neutron. How do I know this? Because I'm having one proton here, and two neutrons here, and one neutron here. So gray shaped particles are all neutrons. Black shaped particles are all protons. The proton number of particle B. Proton number of particle B, since it contains two protons, so it could be 2. The nucleon number or mass number of particle B. So mass number would be sum of nucleons, that is protons and neutrons, it would be 4. At very high temperature is needed to force the nuclei together. Explain why. So as the question states, they are combining these two nuclei, and this results in the formation of a heavier nuclei and a single particle. So why high temperature is needed to fuse them? See, this contains a positively charged proton and this also contains two positively charged protons. So if we want them to come closer, then they would be repelling by electrostatic repulsion. That means we need some energy to overcome that repulsion. See, this would be repelling this, and they would be having repulsion. So I can write repulsion here. Why? Because according to electrostatics, like charges, they repel. That means this is positive and this is positive, they are repelling each other. So if we want them to converge into a single entity, what we need is we need high temperature. See, why we need high temperature? Because high temperature leads to what? According to kinetic molecular model, higher kinetic energies. So if we are having higher kinetic energies available here, then these particles would vibrate much rapidly. As a result, they can converge or they diffuse it into each other because of very high kinetic energy. And that high kinetic energy leads to basically fusion of two atoms and helium. So what I can write here is nuclear repulsion can be overcome by higher or greater kinetic energies. That can only be possible that can only be possible with higher temperature.